Imagine that one night, while Earth is still turning quietly under your feet, while oceans breathe against their shores, while cities glow like warm veins across the darkness, you are given an impossible chance. You are placed inside a spacecraft that can keep moving outward, beyond the Moon, beyond Mars, beyond Jupiter, beyond the cold blue orbit of Neptune, beyond the last familiar sunlight of home, until one day you cross into the deep silence between the stars. And then, after travelling farther than almost anything humanity has ever built, you turn around. You look back. The question sounds simple, almost like a child's question. What would you see if you left the solar system and looked back? But the answer is not simple at all, because the deeper you go into space, the more your idea of home begins to collapse. The planets do not hang there like glowing marbles in a neat classroom model. The orbits do not shine like silver rings. Earth does not remain a beautiful blue world waiting for your eyes. The farther you travel, the more everything you love becomes smaller, dimmer, quieter, until the whole history of life, every forest, every ocean, every human voice, every dream, every war, every song, every face, becomes less than a point of light. Before we begin this journey, ask yourself something strange. If you were far enough away from Earth, would you recognize it? If the sun became just one more star in a black sky, would your mind still know that this ordinary-looking point was the center of your entire life? And if the solar system has no glowing border, no wall, no final gate, how would you even know that you had left it? This is where the mystery begins. Space does not reveal itself like science fiction. It does not place labels on the darkness. It does not show you neat circles around planets. It hides its most important truths inside distances so large that your brain almost refuses to hold them. So while this story moves outward, slowly and calmly, keep one thought close. The most shocking thing you would see after leaving the solar system is not a giant cosmic structure. It is the terrifying absence of one. And as we move into that silence, stay with this journey. Let your imagination drift slowly outward, and if this kind of cosmic question makes your mind feel both small and awake, then take a calm moment to like, subscribe, and share your own thought in the comments. From how far away do you think Earth would finally disappear from human eyes? Not from a telescope, not from instruments, from you, from naked vision, from the ancient human act of simply looking. Because that is the heart of this journey. We are not just leaving planets behind, we are watching reality strip away our illusions about what home looks like from outside. At first, nothing feels impossible. You launch from Earth, and Earth is still enormous beneath you. The blue atmosphere curves softly at the edge, thin and delicate, almost like a glowing breath wrapped around stone. Clouds move across oceans in white spirals. Continents drift past like old maps. Night cities shimmer in golden networks. The moon waits nearby, grey and silent, already reminding you that space is not empty in the way a room is empty. Space is vast, open, and without comfort. From low Earth orbit, Earth still fills much of your view. It is not a dot. It is not distant. It is a world so large that your mind can still believe it is the universe. This is the first illusion of space travel. When you are close to Earth, you do not feel how small Earth is. You feel how huge it is, how powerful, how complete. But that feeling will not survive the journey. As you move beyond the orbit of the moon, Earth begins to change. The moon no longer looks like the only other world. It becomes a companion point. Earth and moon together form a system. This is already a profound shift. From Earth, the moon is the bright object in our sky. From deep space, Earth is the brighter one. Earth shines because sunlight reflects from clouds, oceans, ice, and atmosphere. It has color. It has life's signature in the most visual sense. Blue, white, brown, green. The moon is duller, darker, more ancient looking. From this distance, you begin to see something that humans did not truly feel until the space age. Earth is not the floor of reality. Earth is an object, a fragile object, a sphere floating in blackness. The first twist is that space does not become brighter as you rise above the atmosphere. It becomes darker. On Earth, sunlight scatters through air and fills the sky with blue. In space, without air, sunlight travels in straight lines. The sun is blinding, but the sky around it is black. This is why astronauts can see a black sky, even while standing in full sunlight on the moon. Darkness is not the absence of the sun. Darkness is the absence of scattering. And as you leave Earth, this lesson becomes stronger. You're not entering a glowing cosmic ocean. You're entering a place where light exists only where it strikes something. Between those things, darkness remains almost perfect. At the distance of Mars, Earth is already losing its emotional size. It is still bright, but it is no longer a world your eyes can understand. It is a point. Perhaps a blue-white star-like object near the sun, depending on where Earth is in its orbit. The moon may be close beside it, but to your naked eye it might already merge into the same tiny spark. Think about that. The moon, which controls tides, inspired calendars, lit ancient deserts, pulled myths out of human minds for thousands of years, becomes visually swallowed by Earth's tiny light. And Earth itself, which contains every human being, every tree, every ocean animal, every mountain and memory, becomes a bright dot among darkness. As your spacecraft moves farther outward, the inner planets begin to compress toward the sun. Mercury, Venus, Earth, and Mars all live close to the central light compared with the wider solar system. From the outer regions, they would appear crowded around the sun's glare. Venus may shine brightly from certain angles, but close to the sun from your viewpoint, it could be difficult or impossible to pick out without shielding and instruments. Earth becomes worse. The same sunlight that makes Earth visible also hides it. The sun dominates everything. Even from billions of kilometers away, the sun is powerful enough to overwhelm the delicate reflections of planets nearby. This is one reason finding exoplanets around other stars is so difficult. Planets are faint, stars are overwhelming. A solar system is not a chandelier of planets. It is one blazing furnace with tiny dust-like companions lost in its glare. Passing through the asteroid belt, another illusion breaks. Many people imagine the asteroid belt as a dangerous field of tumbling rocks, crowded and chaotic like a storm of stones. But the real asteroid belt is mostly emptiness. The asteroids are spread across enormous distances. A spacecraft can pass through without weaving dramatically between boulders. You could travel for long stretches and see nothing. This matters for our question, because it teaches us something essential. The solar system may contain many objects, but visually, from within it, it is still almost entirely dark. Objects are separated not by kilometers in any ordinary sense, but by spaces so large that even worlds become lonely. Jupiter is the first planet after Earth that may truly impress you again. As you approach or pass its region, Jupiter is enormous compared with Earth. It is a giant ball of hydrogen and helium, wrapped in storms, bands, and a magnetic field so large it is like a kingdom. If your path brought you near Jupiter, it could fill your view, with its moons moving around it like a miniature planetary system. But if your goal is simply to leave the solar system and look back, Jupiter also becomes a lesson in temporary importance. For a while it feels like the center of everything, then distance takes it away. Behind you, Jupiter shrinks into a bright point. Its moons vanish first, its bands vanish, its storms vanish. Even the great red spot larger than Earth becomes invisible. Scale is merciless. Distance removes detail before it removes light. Saturn offers one of the most beautiful possible goodbyes. If you passed close enough, its rings would seem almost unreal. A flat, shining disk of ice particles and dust. Not solid, not smooth, but from far away appearing as a delicate cosmic blade around the planet. Yet Saturn too fades. Its rings, so grand in telescopes, are thin in reality compared with the size of the planet and the distances around it. Once you're far beyond Saturn, the rings disappear into the point of Saturn's light. This is one of the deeper truths of looking back from space. Beauty depends on distance. A planet can be magnificent nearby and invisible from afar. Reality has not changed. Only your position has. And the universe does not preserve beauty for human eyes. Past Uranus and Neptune, the sun begins to feel different. It is still the brightest object in your sky, but it no longer looks like the huge commanding disk we know from Earth. From Neptune's distance, sunlight is far weaker than it is at Earth, because light spreads out with distance. The sun would still be intensely bright compared with other stars, but its apparent size would be much smaller. On Earth, the sun and moon appear about half a degree across. From Neptune, the sun's disk would be tiny, though still visible as a disk to sharp eyes or instruments. The warmth that defines daytime on Earth is gone. Sunlight there is hundreds of times weaker than at Earth. Daylight on Neptune's orbit is more like a deep twilight compared with our world, yet the sun remains powerful enough to reveal that you are still inside its realm. But what is that realm? This is where the question becomes tricky. Many people might say the solar system ends at Neptune. That seems natural because Neptune is the outermost major planet, but Neptune is not the edge. Beyond Neptune lies the Kuiper Belt, a vast region of icy bodies, dwarf planets, frozen remnants from the solar system's formation. Pluto is there, not as the last planet but as one member of a wider population. Eris, Haumea, Makemake, and many smaller objects inhabit this outer region. If you travelled through the Kuiper Belt, would it look like a belt? Almost certainly not. You would not see a glowing ring of icy worlds around the sun. You would see darkness, with rare objects separated by immense gaps. The word belt helps scientists describe a population and region. It does not mean the human eye would see a visible band. Looking back from the Kuiper Belt, the solar system would already be failing as a visual idea. The sun would be the main thing, a brilliant small light. The planets would mostly be hidden in its glare or too faint and tiny to separate without instruments. Earth would not be a recognizable blue dot to the naked eye. It would be buried near the sun's brightness, sometimes on one side, sometimes another, depending on orbital geometry. From a spacecraft with a carefully shielded camera, perhaps you could capture Earth as a tiny point, as Voyager 1 did in the famous pale blue dot image. But to your eyes, without help, home would be effectively gone. The pale blue dot is important because it is one of the closest real answers humanity has to this question. In 1990, Voyager 1, already beyond the orbit of Neptune and far above the plane of the planets, turned its camera back toward the inner solar system. Earth appeared as a tiny speck, less than a pixel, caught in a ray of scattered sunlight inside the camera optics. It was not a grand image, it was not sharp, it did not show oceans or continents, it showed something more disturbing, the entire human world reduced to a nearly invisible point. Carl Sagan later described it with words that still feel like a quiet wound in human pride. On that dot, everyone you love, everyone you know, every human who ever lived, existed. And from Voyager's distance, Earth was already almost nothing. Now imagine going farther. The Voyager image was taken from about 6 billion kilometers away, roughly 40 astronomical units from the Sun. That is far beyond Neptune's orbit, but it is still not truly outside the Sun's influence. It is still close compared with the full scale of the solar system. If Earth looked that small from there, what happens from 10 times farther, 100 times farther, 1,000 times farther? Earth does not remain a dot forever. It becomes too faint, too close to the sun's glare, too lost in the black. It does not disappear because it stops existing. It disappears because vision has limits. The universe is full of things that are real, but visually absent. As you continue outward, you approach a boundary that is not made of rock or ice, but of particles and magnetic influence. This is the Heliosphere, the vast bubble carved by the sun into interstellar space. The sun does not only emit light, it releases a stream of charged particles called the solar wind. This wind flows outward through the solar system, carrying the sun's magnetic field with it. Eventually, far beyond the planets, this solar wind slows as it meets the thin material between stars. The region where it slows dramatically is called the termination shock. Farther out lies the heliopause, often described as the boundary where the solar wind's outward pressure balances the pressure of the interstellar medium. Voyager 1 crossed the heliopause in 2012, Voyager 2 crossed it in 2018. These were historic moments because human-made objects had entered interstellar space, at least by the definition of leaving the sun's plasma bubble. But here is the twist. If you were riding beside Voyager when it crossed the heliopause, you would not see a wall. You would not see the darkness change colour. You would not see a glowing shell around the sun. You might detect changes with instruments, more galactic cosmic rays, fewer solar particles, changes in plasma environment. But visually, the crossing would be almost nothing. The most important boundary of the solar system from a human emotional point of view would be invisible. This is one of the most humbling facts about cosmic geography. The universe does not mark its borders for eyes. It marks them in fields, particles, velocities, pressures, and mathematics. Once you're beyond the heliopause, looking back becomes even stranger. The sun is still bright, but now it is becoming star-like in a deeper sense. It is no longer the overwhelming disk of Earth's sky. It is one star among many, though still the brightest star in your local view because you're still relatively close to it compared with other stars. The planets are gone from unaided sight. There is no visible solar system, there is no ring of orbits, there is no shining family portrait. There is only a bright star in a sky of other stars, and somewhere close to that star from your viewpoint, too faint and overwhelmed to matter, is Earth. This is perhaps the most important answer. If you left the solar system and looked back, you would mostly see the Sun. Not the solar system, not Earth, not the planets, the Sun. Our entire cosmic neighborhood, when reduced to visible light from far away, becomes almost entirely one point. The planets do not glow by themselves, they reflect sunlight. Their brightness falls with distance, and their separation from the Sun becomes tiny when seen from far away. A mature solar system like ours is visually modest. It is not a glowing machine, it is a gravitational arrangement, not a visible sculpture. And yet, if you had scientific instruments, the story would deepen. A telescope with enough power and careful shielding could search near the Sun's glare for tiny planetary points. Infrared instruments might detect heat from planets, especially giant planets like Jupiter, though even that becomes extremely challenging with distance. Spectroscopy might reveal clues. If you observed the Sun over time from far away, you might detect small dips in brightness if a planet crossed in front of it from your line of sight. This is called the transit method, one of the major ways we detect exoplanets. You might detect the Sun wobbling slightly due to the gravitational pull of Jupiter and the other planets. This is related to the radial velocity method. In other words, from far away, the solar system might not be seen as a picture. It might be inferred as a pattern. This is exactly how we discover many other worlds. We do not usually see exoplanets directly like little globes beside their stars. We detect their shadows, their gravitational tugs, their heat, their influence on starlight. If aliens were looking at our solar system from far away with advanced instruments, Earth might be detectable only under favorable conditions. They might see oxygen, water vapor, methane, carbon dioxide, or seasonal hints in the light reflected from Earth, if they had extraordinarily capable instruments and the right geometry. But to a naked alien eye from interstellar distance, the solar system would be nothing more than a star. That is what we would see too. The next boundary is even more mysterious, the Oort Cloud. Unlike the heliopause, which spacecraft have actually crossed, the Oort Cloud remains a theoretical but strongly supported region. It is believed to be a vast spherical swarm of icy bodies surrounding the Sun at enormous distances, perhaps beginning thousands of astronomical units away and extending tens of thousands, maybe up to around 100,000 astronomical units. These icy bodies are thought to be the source of many long-period comets. The Oort Cloud is not a cloud like fog. It is not visible as a glowing shell. Its objects are likely separated by huge distances. If you travelled through it, you would probably see nothing nearby for a very long time. But gravitationally, it may represent the Sun's outermost storehouse of ancient material. At the inner Oort Cloud, the Sun is already much dimmer. It still shines brighter than other stars if you're not too far, but its dominance begins to weaken. At thousands of astronomical units, the Sun may still be the brightest star-like point, but it no longer feels like a parent in the sky. It feels like one member of a larger darkness. At tens of thousands of astronomical units, you're approaching distances measured in fractions of a light year. Light from the Sun takes months to reach you, then perhaps more than a year. Looking back is now literally looking back in time. If you are 1 light year away, you see the solar system as it was 1 year ago. If Earth went through a storm, a war, a birth, a sunrise, a volcanic eruption, you would not see its present. You would see the light that left earlier. Distance turns vision into memory. This is one of the deepest twists of the journey. When you look back from far away, you're not only seeing a smaller solar system, you're seeing an older one. The farther you move, the more the present slips away. From the outer Oort Cloud, if you could somehow observe Earth in detail, you would be seeing Earth from months or years ago. From another star, you might see Earth years in the past. From across the galaxy, thousands of years in the past. From another galaxy, millions of years in the past. Space does not allow a universal now to appear visually. Light carries history, not instant reality. The sun itself begins to change psychologically. From Earth, the sun is not just a star. It is day, warmth, weather, food, photosynthesis, time, shadow, color, life. But from far outside the solar system, the sun becomes a point of light. A star. A thing you could cover with your thumb if you were imagining a human hand against the window of the spacecraft. This transformation is almost cruel. The star that powers every leaf and ocean current becomes visually ordinary. It may still be scientifically extraordinary to you because you know what it is, but the eye alone cannot honor it. The eye sees brightness and position. The mind supplies meaning. If you look around from interstellar space, the constellations begin to shift, but not dramatically at first. Stars are so far away that moving across the solar system, or even into nearby interstellar space, changes the sky only slightly. The nearest stars show the greatest shift. Alpha Centauri, Barnard's star, Sirius, and others may appear in slightly different positions as your viewpoint changes. But the familiar constellations are patterns created from Earth's perspective. Travel far enough over light years, and those patterns distort. Orion will not remain Orion forever. The Big Dipper will not remain the Big Dipper. The sky we think of as permanent is local and temporary. Even the map of night is a homemade illusion. Would the Milky Way look different after leaving the solar system? Not immediately. You're still inside the Milky Way, still embedded in its disk, still surrounded by stars and dust. The great band of the galaxy would still stretch across the sky if your view were unobstructed. But without Earth's atmosphere, without light pollution, without the blue scattering of daylight, the stars would appear with sharp intensity when you are shielded from the sun. Space itself would not make stars larger or magical. It would remove atmospheric twinkling. Stars would look steady, piercing, silent. The Milky Way would be a luminous river of unresolved stars and dust lanes, not because you left the solar system, but because you left the atmosphere behind. Yet the sun's glare remains a practical problem. If you turn directly toward the sun, your eyes or cameras must be protected. Just as on Earth you cannot stare safely at the sun, in space you need shielding. Many images of faint objects near bright stars require blocking the star's light, like using a coronagraph. This matters because the planets you want to see are close to the sun from far away. Looking back is not simply a romantic act. It is an optical challenge. The solar system hides behind its own star. Now imagine you are far enough away that the sun is just one bright star among others. Which star would it look like? Our sun is a G-type main sequence star, not the largest, not the smallest, not the brightest, not the faintest. From a few light years away, it would be visible to the naked eye if you knew where to look, though its brightness would depend on distance. From Alpha Centauri, about 4.37 light years away, the sun would appear as a bright star in the constellation Cassiopeia from that viewpoint. It would not look like a yellow disk. It would be a point. Around that point would be everything we call home, but without instruments, no Earth. This gives us a chilling comparison. When we look up at night and see stars, some of them may have planets, some may have rocky worlds, some may have oceans, some may have moons, storms, auroras, volcanoes, maybe even life. But to us they are only points. If we left the solar system and looked back, we would learn what it means to become one of those points. The night sky is full of homes that do not announce themselves. The universe may be crowded with worlds, but vision reduces them to silence. The planets themselves, if seen with instruments from far away, would tell different stories. Jupiter would be the easiest major planet to detect by gravitational influence. It is massive enough to make the sun move around a shared center of mass that sometimes lies outside the sun's surface. Saturn contributes too. Earth's gravitational tug is tiny by comparison. Earth's visual brightness can be meaningful at the right angle, because it reflects sunlight and has clouds, but it is still extremely close to the sun from distant viewpoints. Neptune and Uranus are dim, cold, and far. Mars is small. Mercury is close to the sun. Venus is bright but also close. The solar system's architecture can be measured, but not casually seen. If you could somehow see the orbits, they would not be glowing circles. Orbits are paths, not objects. They are the consequences of gravity and motion. A planet does not leave a luminous track behind itself as it travels. The beautiful diagrams we see in books are teaching tools. They are maps of behavior, not photographs. This is another twist. Much of what we think the solar system looks like is actually what it means mathematically. The real view is sparse, dark, and dominated by a star. Even the plane of the solar system, called the ecliptic, would be mostly invisible. Many planets orbit roughly in the same flat plane because the solar system formed from a rotating disk of gas and dust. But after billions of years, the original protoplanetary disk is gone. Only planets, asteroids, comets, dust, and scattered debris remain. There is zodiacal dust in the inner solar system that can scatter sunlight and create faint zodiacal light, but from far away it would not create a dramatic glowing disk like images of young star systems. Young systems with thick dust disks can be spectacular in telescope images. Our solar system is mature, cleaned out, subtle. Its history is visible in orbits and leftover bodies, not in a bright disk. The more you look back, the more you realize that leaving the solar system is not like leaving a city and seeing its skyline. A city announces itself with lights, towers, roads, heat. The solar system does not. The solar system is a collection of bodies bound by gravity to one star, spread across distances so vast that even light needs hours, days, months, or years to cross them. It is less like a city, and more like a few grains of dust spread across a stadium, with one lamp in the middle. And even that comparison fails because space is emptier than our metaphors. At this point in the journey, the emotional meaning becomes hard to avoid. From Earth, humans argue over borders, names, possessions, histories. We divide the surface into countries and cities. We speak as if mountains and oceans are permanent. But from just a few billion kilometers away, Earth is smaller than a pixel. From interstellar space, it vanishes. This does not make human life meaningless. It makes it rare. It means that all meaning we know is concentrated in a place the universe does not visually emphasize. The cosmos is not arranged to highlight us. We are the ones who must learn to notice ourselves. There is another possible twist. If you looked back at the solar system not in visible light but in radio waves, infrared, ultraviolet, X-rays or particles, the view could change. The sun emits across the electromagnetic spectrum. Its magnetic activity, solar wind, and interactions with interstellar space create structures that instruments can detect. The heliosphere has a shape influenced by the sun's motion through the interstellar medium. It may have a nose and tail-like structure, though the details are complex. Energetic neutral atoms can map regions of interaction. In ultraviolet, certain emissions may reveal boundaries, but none of this creates the simple visual image people expect. The solar system's true shape is multi-layered and wavelength dependent. Eyes see only a tiny slice of reality. If you had a powerful enough detector, Earth itself might betray life, not through city lights from interstellar distances, which would be incredibly faint and hard to detect, but through atmospheric chemistry. Earth's atmosphere contains oxygen produced largely by photosynthetic life, along with methane in disequilibrium and water vapor, carbon dioxide, ozone, and other compounds. The combination can suggest biological activity. From far away, Earth's greatest signature might not be blue beauty, but chemistry. Life does not need to be seen as forests and animals to leave a mark. It can alter a planet's air. But from the human window, there is no such comfort. You see the sun. You see stars. You know Earth is there, but knowledge has replaced sight. This is a profound stage in any cosmic journey. At first, seeing makes you believe. Later, belief must survive without seeing. You must trust the mathematics, the navigation, the memory. Home continues to exist even when your eyes cannot find it. That is not just science. It is a strange emotional truth. The farther you travel, the more communication changes too. Radio signals from Earth weaken with distance, though focused transmissions and deep space networks can still communicate with spacecraft over enormous ranges. Voyager signals are incredibly faint by the time they reach us, yet we detect them with giant antennas and careful engineering. If you were out there, messages from Earth would take hours, then days, then months, then years. A conversation would become impossible in the ordinary sense. Looking back would not only show you a faint sun, it would remind you that even voices travel at light speed. Love, command, warnings, music, all become delayed by distance. At 1 light day from the sun, sunlight takes 1 day to reach you. At 1 light year, 1 year. The solar system does not end neatly before time delay becomes meaningful. Even within it, Communication with outer spacecraft is slow. This is part of what makes deep space psychologically alien. On Earth, distance can often be overcome by speed. In space, distance becomes time itself. To look back is to receive the past. To speak back is to send a message into someone else's future. If you continued toward another star, the sun would gradually dim. Its apparent brightness would fall with the square of distance. From tens of light years away, the sun would be a modest naked-eye star or perhaps invisible, depending on distance and conditions. From hundreds of light years, it would require instruments. From across the galaxy, it would be lost among billions. The solar system would not just be invisible. Even the sun would become one statistical point in the Milky Way's mass of stars. This is where the question becomes almost unbearable. From far enough away, not only Earth disappears, not only the planets disappear, but the sun itself disappears into the crowd. And yet, if you zoom back in with impossible precision, the structure is still there. Earth still orbits, Jupiter still pulls, comets still fall inward after long ages in the Oort Cloud, dust still drifts, the heliosphere still breathes with the solar cycle, the planets still keep time with gravity. The solar system does not need to be visible to be real. This is one of the final lessons of the journey. Reality is not limited to appearance. The most important structures in the universe are often invisible until interpreted. Now let us slow down and imagine one exact moment. Your spacecraft is beyond the heliopause. You turn it carefully. The sun is behind you now, not as a warm disk, but as a fierce star. You block most of its glare with an instrument. Around it, the blackness becomes available. You search for Earth. You know where it should be. The computer marks a location. The camera gathers photons for a long exposure. At first, the image is noise, specks, cosmic rays, sensor artifacts, scattered light. Then, after processing, a dot appears. Maybe a faint point in a field of darkness. You ask, is that Earth? The answer depends on calculation. It is not obvious. The most meaningful dot in your life must be confirmed by data. That is the opposite of how we live on Earth. On Earth, home is obvious. It is beneath your feet. You do not need proof of it. Gravity holds you. Air enters your lungs. The ground resists your weight. But in deep space, home becomes an inference. It becomes coordinates, photons, a pale point near a bright star. The journey outward is also a journey from instinct to abstraction. You begin with Earth as experience. You end with Earth as evidence. This is why the famous pale blue dot image changed so many minds. It did not show Earth in detail. It removed detail. It forced the viewer to understand that detail is a privilege of closeness. From afar, the universe does not show your face, your street, your country, your species. It shows a point, and yet that point contains everything. The image is powerful because it combines maximum smallness with maximum meaning. It is almost nothing visually and almost everything emotionally. Now consider what would happen if an alien civilization somewhere nearby looked at the sun. They might catalogue it as a stable main sequence star. They might estimate its mass, temperature, luminosity, age, and metallicity. They might detect planets if their instruments were advanced. Perhaps Jupiter first. Perhaps Venus or Earth through transits if geometry aligned. But they would not see our histories. They would not see languages, music, grief, science, kindness, fear. The universe hides experience behind light. A planet can be full of consciousness and still look like a speck. This should not make the cosmos feel empty. It should make every world feel mysterious. When you look at a star, you might be looking at a place where someone else's entire meaning is hidden by distance. Their oceans, if they exist, are invisible. Their storms are invisible. Their children, if they exist, are invisible. Their sky, their myths, their questions, all reduced to the same thing our solar system becomes, a star-like point in the dark. If you left the solar system and looked back from above the plane of the planets, perhaps the geometry would help. You might see the inner planets separated slightly better from the sun than if you were along the plane. This is why Voyager 1's family portrait was possible. It viewed the solar system from an angle above the ecliptic and captured several planets. But even then, Earth was tiny. From a carefully chosen viewpoint with instruments, you can assemble a portrait. But the human eye alone would not receive a glorious diagram. The grand family of worlds would have to be reconstructed by intention. There is also dust. The solar system contains interplanetary dust, cometary dust, asteroid fragments, and tiny particles. From Earth, sunlight scattered by dust creates zodiacal light, a faint triangular glow after sunset or before sunrise in dark skies. From outside, could this dust make the solar system visible as a faint disk? In principle, with sensitive instruments, dust emission and scattered light can reveal structures. Astronomers study debris disks around other stars, but our zodiacal dust is faint. To the unaided eye from far away, it would not outline the solar system like a shining halo. Again, the real structure is too subtle for simple vision. The same is true of comets. When comets come near the Sun, they can become spectacular because solar heating releases gas and dust forming comas and tails. But far from the Sun, in the outer solar system or Oort Cloud, comet nuclei are dark, frozen, and small. They do not announce themselves. The Oort Cloud may contain vast numbers of such bodies, but it would not look like a snowstorm. It would be more like a nearly empty cathedral of darkness, with tiny silent relics separated by astronomical distances. At some point your mind may ask, if everything is so invisible, why do we call it a system? The answer is gravity. The solar system is defined by relationships, not appearance. Earth belongs to the solar system because it orbits the Sun. Neptune belongs because it orbits the Sun. Kuiper Belt objects belong because they are bound to the Sun. Oort Cloud comets, if bound, belong at the edge of the Sun's gravitational influence. The system is an invisible pattern of motion. If you could watch over millions of years from far away, you would see the dance. But in a single glance, you see almost nothing. This is another human limitation. Our eyes capture moments. The solar system reveals itself through time. A planet is not just where it is the path it follows. A comet is not just a frozen nucleus. It is an orbit stretching from the deep cold to the inner fire. The heliosphere is not just a boundary, it breathes with solar activity. Even Earth is not just a sphere, it is a moving world rotating, orbiting, changing seasons, reflecting life in cycles. To understand the solar system from outside, you need patience, records, instruments, and physics. A glance gives you the sun, science gives you the family. Now imagine you had a magical time lapse. Not magic in a false sense, but a visualization based on real motion. From far outside, over years, the planets would move around the Sun. Mercury would circle rapidly, Venus smoothly, Earth yearly, Mars more slowly, Jupiter in about 12 Earth years, Saturn in about 29, Uranus in 84, Neptune in 165. The solar system would become visible through motion if your instruments could see the planets. Time would draw the orbits that light cannot. The diagram would emerge not as glowing lines but as repeated positions. Motion makes hidden structure visible. But your actual eyes at one moment still see a star. That tension between what is true and what is visible is the heart of astronomy. We know galaxies contain dark matter not because we see it directly, but because gravity reveals it. We know black holes exist because of motion, radiation, lensing, gravitational waves, and shadows of hot gas. We know exoplanets exist because stars dim and wobble. The solar system from outside would teach the same lesson. Seeing is not always believing. Sometimes measuring is believing. If you travel to the distance of the nearest stars, the Sun would become part of their sky. From Proxima Centauri's neighborhood, the Sun would be a bright star but not the brightest possible star in the sky. It would have a position in alien constellations. Earth would be lost. Radio leakage from Earth, the unintentional broadcasts that spread outward, would be extremely weak and difficult to detect over interstellar distances. Powerful directed signals would be another matter, but Earth is not a lighthouse in the simple way people imagine. Our technological presence is fragile and faint compared with cosmic noise. City lights are another common fantasy. Could you see Earth's city lights from outside the solar system? No, not with naked eyes, and not easily even with technology from interstellar distances. City lights are tiny compared with reflected sunlight from the planet, and Earth itself is tiny compared with the Sun. At night on Earth, cities feel bright because you are close. From space near Earth, city lights are visible on the night side. From far away, they vanish. Civilization's glow is powerful emotionally but physically small. This leads to a powerful contrast. Photosynthesis changed the atmosphere of Earth on a planetary scale. Microbes altered the chemistry of the air over billions of years. Life's quiet biological work may be more detectable across space than our electric lights. The forest may speak louder than cities in the language of spectra. The smallest organisms shaped a signal larger than empires. From outside the solar system, humanity's proudest constructions vanish first, while the ancient breathing of the biosphere remains the deeper planetary clue. If you could see Earth as a single pixel through a huge telescope, its brightness and colour might change as it rotated. Oceans, clouds, deserts, forests and ice reflect different amounts and colours of light. Over time, a distant observer might infer continents and weather patterns from tiny variations. Seasonal changes might appear. The so-called red edge of vegetation, a sharp change in reflectance caused by chlorophyll, has been discussed as a possible biosignature, though detecting such things from interstellar distances is extremely challenging. But the idea is beautiful. Even when Earth is too small to image, its changing light can carry hints of living surfaces. Yet this kind of knowledge would require instruments far beyond ordinary looking. The naked view remains humblingly plain. This difference between instrument and eye is another major theme. Humans evolved to survive on Earth, not to read solar systems from light years away. Our eyes are tuned to daylight, predators, fruits, faces, fire, movement. The universe is mostly too faint, too far, too slow, too energetic, or too subtle for our senses. Science is how human perception escapes the body. Telescopes are extended eyes. Spectrometers are extended color vision. Radio antennas are ears for wavelengths we cannot hear. Spacecraft are our touch extended into darkness. When you leave the solar system, you become dependent on those extensions. Without them, space is almost blank. With them, it becomes layered with structure. The heliosphere becomes a measurable bubble. The sun becomes a spectrum. Planets become orbital signatures. Dust becomes infrared glow. Cosmic rays become counts. Magnetic fields become data. The solar system changes from a picture to a data set, and strangely, that data set is more truthful than the picture. Now let us return to the moment of looking back. Suppose you are at 1,000 astronomical units. 1 astronomical unit is the average distance between Earth and the Sun, about 150 million kilometers. At 1,000 astronomical units, you are far beyond the planets, and much farther than Voyager is today compared with the inner solar system. The Sun's light is 1 million times weaker than at Earth, because brightness falls with the square of distance. Still, the Sun would be very bright compared with other stars, but the sense of solar warmth is gone. Earth from there would be tiny beyond imagination. Its maximum angular separation from the Sun would be about 1,000th of a radian, roughly a few arc minutes, but its brightness would be extremely faint and overwhelmed unless observed carefully. To the eye, no Earth. At 10,000 astronomical units, the Sun is still gravitationally dominant for many objects, but visually it is more star-like. The inner solar system is compact beyond recognition. The entire orbit of Earth would subtend a very small angle. The planets are deeply hidden. If you had not come from Earth, you might not suspect a living world near that star by sight alone. This is a sobering truth for the search for life. Living planets do not necessarily stand out visually. The universe may hide life not because life is absent, but because distance is cruel. At 100,000 astronomical units, roughly over 1.5 light years, you may be near the outer reach often associated with the Oort Cloud, though the exact extent is uncertain. From there, the Sun is still visible but not overwhelmingly special. Nearby stars begin to matter more. The gravitational influence of passing stars and the galactic tide can perturb distant comets. The Sun's hold weakens at the edges. This is not a wall, but a fading authority. At Earth, the Sun is ruler. In the outer Oort Cloud, it is a distant monarch whose command can be disturbed by other stars and the galaxy itself. This idea, that the solar system fades rather than ends, is essential. Human minds like borders. We like lines on maps. But cosmic systems often have gradients. Atmospheres thin gradually. Magnetospheres stretch and change. Stellar winds meet interstellar medium in complex ways. Gravitational influence declines, but does not abruptly vanish. The solar system has several edges depending on what you mean. Planetary edge, Kuiper Belt edge, heliopause, Oort Cloud, gravitational dominance. So if someone asks when you have left the solar system, the honest scientific answer is, which solar system do you mean? the planetary system, the Sun's wind bubble, the Sun's comet cloud, the Sun's gravitational family. This is why the title question is so powerful. It seems visual, but it forces definitions. If you leave the planets and look back, you see a bright sun and maybe, with instruments, some planets. If you leave the heliosphere and look back, you see the Sun as a star and no visible boundary. If you leave the Oort Cloud and look back, the Sun is one star among many, with the entire planetary system invisible. If you leave far enough, even the Sun becomes part of the Milky Way's glitter. The answer depends on distance because reality changes slowly, not dramatically. Another twist. From far away, the Sun's colour might not look as yellow as people imagine. In space, the Sun is essentially white to human eyes, though classified as a G-type star with a surface temperature around 5,778 Kelvin. Earth's atmosphere scatters shorter wavelengths and can make the Sun appear yellowish or reddish near the horizon. From space, without atmospheric filtering, the Sun is a brilliant white light. From far away as a star, its colour would be subtle, not the saturated yellow often shown in art. Many star colours are delicate to human eyes, unless contrasted or photographed with techniques that enhance them. And what about the planet's colours? Earth is blue because of oceans and Rayleigh scattering in the atmosphere, with clouds bright white. Mars is reddish due to iron oxide dust. Neptune appears blue due to methane absorption and atmospheric scattering, though images may be processed. Jupiter and Saturn show bands from clouds and chemistry. But from outside the solar system, these colours are not visible to your naked eye. They are truths erased by distance. This is another lesson. Colour is not only about an object, it is about resolution, light, and proximity. You might expect that looking back from outside would make the solar system seem peaceful. In one sense, it would. No sound, no visible chaos, no dramatic motion in a single moment. But scientifically, the solar system is alive with violence and energy. The Sun erupts with flares and coronal mass ejections. Jupiter's magnetic field traps radiation. Asteroids collide over long times. Comets vaporize near the Sun. Planets are bombarded by particles. Earth's magnetic field shields life from solar wind. The calm view hides a dynamic environment. Space often looks still because its timescales and distances overwhelm our senses. This hidden violence is part of the twist. From outside you might see one serene star. But inside that star system, worlds have been melted, bombarded, frozen, stripped, reshaped. Mercury is scorched and cratered. Venus is a greenhouse furnace with crushing atmosphere. Earth is alive but geologically restless. Mars is a desert with ancient river scars. Jupiter is a storm world. Io erupts with volcanoes. Europa hides an ocean under ice. Saturn's moon Titan has methane lakes. Enceladus sprays water-rich plumes. Neptune has supersonic winds. Pluto has nitrogen ice plains. The solar system is a library of extremes, but from outside the library looks like a single light. Think about how unfair that seems. An entire collection of worlds, each with its own history, reduced to one point. But this is also how stars appear to us. When we see a star, we do not know at a glance whether it has barren rocks, ocean moons, frozen dwarf planets, storms, rings, or living biospheres. Every point may hide complexity. The night sky is not empty of detail. It is full of compressed detail. Distance compresses stories into light. The solar system's formation is also hidden in that light. About 4.6 billion years ago, the Sun and planets formed from a collapsing cloud of gas and dust. A rotating disk formed around the young Sun. Dust grains stuck together, forming pebbles, planetesimals, planetary embryos, and eventually planets. The inner region became rocky worlds. The outer colder region allowed ices and giant planets to form. Leftovers became asteroids, comets, Kuiper Belt objects, and Oort Cloud bodies. From outside today you would not see this history directly, but the arrangement of worlds, if measured, would reveal the fossil pattern of formation. The solar system is not only a place, it is a frozen record of its birth. Would you see the Sun moving? In a short time? No. But over longer times, yes. The Sun orbits the center of the Milky Way roughly once every 225 to 250 million years. It moves through the local interstellar medium. The planets travel with it, bound by gravity. The whole solar system is not sitting still. It is falling around the galaxy. From far outside and over immense time, the Sun is a moving star carrying a small family of worlds through the galactic disk. We often imagine the planet circling a stationary sun, but the Sun itself is moving. The true path of Earth through space is a spiral-like motion around a moving star within a rotating galaxy. From outside, if you could perceive time deeply, the solar system would be a travelling system, not a static diagram. This adds another layer to looking back. You're not looking at a fixed home. You're looking at a moving home, a system in flight. Earth does not return to the same place in the galaxy after each orbit around the Sun. The Sun has moved on. Every year, Earth loops around a star that is itself moving through the Milky Way. Your childhood home, in the galactic sense, is never in the same place twice. Leaving the solar system means leaving something that was always travelling anyway. If you look back from above the galactic plane, which would require far more than leaving the solar system, the Milky Way itself would eventually become visible as a spiral structure. But from merely outside the solar system, you're nowhere near outside the galaxy. The galaxy remains your environment. The Sun is one star within a local neighbourhood. The scale difference is staggering. Leaving the solar system feels enormous to us because our machines have barely done it. But compared with the galaxy, the solar system is microscopic. The distance to the nearest star is thousands of times larger than the distance to the outer planets. The Milky Way is tens of thousands of light years across. The solar system is a small clearing around one star. This scale creates one of the most important emotional results of the journey. When you leave Earth, Earth becomes small. When you leave the planets, the solar system becomes small. When you think about the nearest stars, the Sun's domain becomes a tiny island. When you think about the Milky Way, even nearby stars become a local cluster of sparks. When you think about galaxies, the Milky Way becomes one island among billions. The mind keeps zooming out, and every centre becomes local. The universe does not seem to have a preferred centre in the way ancient humans imagined. Your home is central to your life, but not to space. And yet, the fact that Earth becomes invisible does not reduce its scientific importance. Earth remains the only world we know with life. From a cosmic perspective, that makes it extraordinary. The universe does not highlight extraordinary things visually. A living planet can look like nothing. A dead star can blaze brightly. A black hole can be invisible while controlling the motion of stars. A tiny moon may hide an ocean. Brightness is not importance. This is a key lesson. Looking back teaches you not to confuse visibility with value. The journey also changes the meaning of sunlight. On Earth, sunlight is immediate and abundant. Plants convert it into chemical energy. Weather systems are driven by it. Human bodies respond to it. Solar panels harvest it. But far away, sunlight becomes weak, cold, almost symbolic. At Saturn, sunlight is about 1% of what Earth receives. At Neptune, less than 1,000th. Beyond the heliopause, it becomes a faint star's offering. The Sun is still powerful, but its power is spread across a sphere of expanding distance. Every photon that reaches you has travelled alone through darkness, mostly without touching anything. Most sunlight never hits a planet. Most of the Sun's energy escapes into space forever. Earth receives a tiny fraction, and that tiny fraction powers almost everything we know. This is another astonishing realization. Life on Earth depends on a microscopic share of the Sun's output. The rest flows outward into the dark. From outside, you see the star, but you cannot easily see the rare planet that captured enough light to grow forests and eyes. The universe wastes light on a scale that only seems wasteful from a human perspective. Physically, light simply travels. Some of it meets worlds, some of it warms dust, some of it goes on for billions of years. If you looked back with a detector sensitive to neutrinos, the Sun would be even stranger. Neutrinos produced in the Sun's core stream outward and pass through matter almost as if it is not there. They reach Earth constantly, passing through your body by the trillions. From far away, neutrinos could reveal the nuclear furnace at the Sun's heart. Visible light from the Sun's surface takes a complicated journey from the core, with energy slowly diffusing outward before escaping. Neutrinos escape more directly. So depending on how you look, you're seeing different layers of the Sun's reality. The eye sees the photosphere. instruments can sense the core. Again, the solar system's true appearance depends on the kind of vision you bring. The Sun also has a solar cycle, roughly 11 years, during which magnetic activity rises and falls. Sunspots, flares, and coronal mass ejections vary. From outside, if you monitored the Sun over time, you could detect changes. The star is not perfectly constant. These variations influence space weather throughout the solar system. Earth's magnetic field and atmosphere protect the surface from most direct harm, but technology can be affected by strong solar storms. From far away, the Sun may look calm, but its magnetic life is restless. The star that appears as a point is actually a rotating sphere of plasma with tangled magnetic fields. If your spacecraft were outside the heliosphere, cosmic rays would be more common. The heliosphere helps shield the inner solar system from some galactic cosmic rays. Beyond it, you are more exposed to the high-energy particles that move through interstellar space. This is not something your eyes would see as a view, but your instruments and body would care. Radiation is part of the invisible landscape. Leaving the solar system is not only about what becomes visible, it is about what begins to reach you. The silence would also be different than people imagine. Space has no air to carry ordinary sound, so you would not hear the sun roaring, planets humming, or stars singing with ears alone. But plasma waves, radio emissions, magnetic vibrations, and particle interactions can be converted into sound by instruments. Space is not silent in data. It is silent to human ears because our ears require pressure waves in air. This is another recurring truth. The universe is full of signals that human senses were not built to receive. Outside the solar system, you would be surrounded by invisible messages. Now consider the direction of home. On Earth, directions are grounded: north, south, east, west, up, down. In deep space, direction becomes relative to stars, velocities, and coordinate systems. Looking back requires knowing where the Sun is, where Earth should be in its orbit, how your spacecraft is oriented. Without navigation, the sky is a sphere of lights. The Sun may be obvious if still nearby, but Earth is not. The emotional act of looking homeward becomes a technical act of pointing accurately. In deep space, nostalgia needs coordinates. This might be one of the loneliest realities. You could be looking exactly toward Earth and see nothing but darkness near a star. You could be facing every person alive and have no visual proof. The distance would erase them. The mind would have to carry what the eye cannot. Space travel at this scale is not only engineering, it is memory stretched across emptiness. And yet, the emptiness is not truly empty. Interstellar space contains atoms, ions, dust grains, magnetic fields, cosmic rays, and photons. It is emptier than the best vacuums on Earth, but not nothing. The Sun moves through this medium. The heliosphere is shaped by its interaction with it. There may be clouds of slightly denser interstellar gas. The solar system passes through changing environments over galactic time. These changes may influence the heliosphere's size and cosmic ray flux, though the details are complex. From outside, you are entering a medium that is thin but real, a cosmic atmosphere between stars. If you look back and imagine the heliosphere, you might picture a bubble around the Sun. But its actual shape is not a perfect sphere. It depends on solar wind, magnetic fields, interstellar flow, and solar cycle. For years, people imagined it with a comet-like tail, but modern data suggests more complex possibilities, perhaps more rounded or croissant-like in some models. The important thing is that the Sun has an invisible protective region, but not a solid wall. The solar system's bubble is a dynamic interaction, not a glass sphere. You would not see it with eyes. You would sail through its physics. The Oort Cloud too is invisible. It may extend so far that the Sun's gravity blends into the gravitational influence of the galaxy and passing stars. Some comets are nudged inward from these distant reservoirs, falling for thousands or millions of years toward the Sun. When they finally enter the inner solar system, they can become spectacular, with tails pointing away from the Sun due to solar radiation and solar wind. From outside, this means the solar system occasionally sends bright messengers inward from its dark edge. Comets are like memories from the formation era, stored in cold darkness until gravity disturbs them. If you were leaving, you might pass none of these comets closely. The outer solar system is too sparse. Human imagination fills space with objects because stories need scenery. Reality gives you distance. This is why deep space missions spend most of their time in transit. The drama is not constant visual change. The drama is endurance. A spacecraft moves through emptiness, guided by math, powered by limited energy, listening for faint signals. The most heroic part of leaving the solar system may not look heroic from a window. It may look like nothing happening for years. Voyager 1 and Voyager 2 are the real symbols of this journey. Launched in 1977, they used rare planetary alignments to visit the outer planets. Voyager 1 flew by Jupiter and Saturn, then headed out of the planetary plane. Voyager 2 visited Jupiter, Saturn, Uranus, and Neptune, giving humanity its only close views of Uranus and Neptune so far. Now both are traveling through interstellar space, still moving outward, carrying golden records with sounds and images of Earth. They are not aimed at a star they will reach soon. Space is too large. They will drift for tens of thousands of years before coming relatively near other stars. They are messages to the future more than vehicles to destinations. If you could fly beside Voyager and look back, you would share its loneliness. The spacecraft does not see Earth with human emotion. It measures, transmits, survives. Its power declines. Its instruments are turned off one by one to conserve energy. Eventually it will fall silent, but it will continue moving. Long after its radio voice ends, it will remain a human artifact in interstellar space, a small metal memory of a species that briefly learned how to throw objects beyond its star's wind. From the outside, it would be nearly impossible to see. Like Earth, like humanity, it becomes invisible at scale. This invisibility is not failure. It is the natural condition of small things in a vast universe. A seed is small, but it can contain a forest. A cell is small, but it can contain life. A planet is small, but it can contain consciousness. Earth's smallness is not the opposite of wonder. It is the reason wonder becomes urgent. Because everything fragile must be understood and protected more carefully, not less. Now, let us imagine the view from far beyond the Oort Cloud, perhaps halfway to the nearest star. The Sun is behind you, a bright but ordinary star. Alpha Centauri ahead may be brighter or comparable depending on your position. The sky has changed. The Sun no longer dominates your sense of orientation. You're in between stellar homes. This is true interstellar space in the emotional sense. No star feels like home anymore. You're between islands of gravity and light. Looking back, the solar system is no longer a place to see. It is a coordinate in the star field. From this distance, if you had a star chart, you could identify the Sun. Without one, it might be just another point. This should make us think differently about every star in the night sky. We identify them by names and constellations, but each is a sun from some viewpoint. Each may have its own gravitational realm. Some are young and violent, some are old and quiet, some are red dwarfs that will burn for trillions of years, some are massive stars that live fast and die violently. Our Sun is one among them, special to us because we orbit it, ordinary in many astrophysical ways. The universe is full of ordinary stars that may host extraordinary stories. If you ask what the solar system would look like in a photograph from light years away, the answer depends on exposure. A normal photograph might show the Sun as a star. A carefully designed observation could block the Sun and perhaps detect planets. A long-term survey could reveal orbital motion. A spectral analysis could suggest planetary atmospheres. But the classic human image of a solar system, with visible planets lined up around a glowing star, is mostly an educational fantasy. Real images of distant planetary systems often show young hot giant planets far from their stars, or disks of dust, not compact Earth-like worlds in clear detail. Directly imaging Earth-like exoplanets is one of the great challenges of astronomy. This tells us something about why the search for another Earth is so difficult. Earth is not just small, it is close to a bright star, it is faint, its signal is mixed with clouds, seasons, atmosphere, and stellar activity. We want to find worlds like ours, but worlds like ours are the hardest to see. Gas giants are easier. Big planets close to stars are easier by transit. Young hot planets are easier in infrared. But a small temperate rocky planet around a sun-like star is a whisper beside a shout. If you left the solar system and looked back, you would understand this problem physically. You would see how efficiently the Sun hides Earth. Now, There is another philosophical twist. The universe may be full of observers asking the same question from their own homes. What would they see if they left their system and looked back? Perhaps they too would find their world vanishing into a star's glare. Perhaps every civilization must eventually confront the same humbling image. Home is not visually obvious to the cosmos. Meaning does not shine across space automatically. It must be carried, communicated, protected, discovered. This has consequences for how we think about intelligence in the universe. We often ask why we do not see signs of other civilizations everywhere. But visibility is hard, distance is hard, signals weaken, time windows may not overlap, civilizations may not broadcast strongly, planets hide near stars, the night sky's silence may not mean emptiness, it may mean difficulty. When you realize how invisible Earth becomes, the silence of other worlds feels less surprising. The universe may not be quiet, we may simply not be sensitive enough, close enough, or looking at the right time. If you look back from outside the solar system, Earth's radiosphere, the expanding shell of our earliest broadcasts would be only about a couple hundred light years across for the oldest signals, and extremely weak. That is tiny compared with the Milky Way. Our technological footprint has barely begun to move through the galaxy. And because many broadcasts were not designed as interstellar signals, they disperse and fade. Humanity has not filled the galaxy with evidence. We have barely whispered into a storm. The solar system from outside also teaches that maps can deceive. In diagrams, the planets appear large and close. In reality, if Earth were the size of a peppercorn, Jupiter would be meters away, Neptune much farther, and the nearest star thousands of kilometers away in a scaled model depending on scale. Space is not just big, it is mostly gaps. The planets are not neighbors in the human sense, they are isolated islands. Looking back from outside, those islands vanish because the gaps dominate. This is why the word void feels appropriate. But even void is not enough. The darkness between planets is not an object. It has no surface. It does not give your mind anything to hold. Humans are pattern-seeking creatures. We look for shapes, faces, stories. Space often refuses to provide them. The solar system's true appearance from outside may be psychologically disappointing at first because it lacks drama. But then the disappointment turns into awe, because you realize the drama was never in the view alone. It was in the scale, the hidden motion, the fact that such invisible architecture produced a living world. Let us think about the sun's gravity from the outside. The sun contains about 99.8% of the solar system's mass. Almost everything else, all planets, moons, asteroids, comets, dust, spacecraft, humans, together makes up a tiny fraction. This is why the sun dominates the system visually and dynamically. The planets matter immensely to us, but mass-wise and light-wise, the sun is the giant. Looking back, you would see this hierarchy clearly. The star rules the view, the planets are subtle details. But Jupiter, though far less massive than the sun, is still crucial. It shaped the architecture of the solar system. Its gravity influenced asteroid belt structure, comet paths, planetary formation, and impact rates. Saturn too shaped resonances and migration histories. The outer giants may have moved in the early solar system, scattering icy bodies outward and inward. The Nice model and related ideas explore how giant planet migration could have reshaped small body populations. From outside, none of this is visible directly. The calm point of the sun hides a turbulent ancient history of migration, impacts, and gravitational rearrangement. Earth's existence depends on that history. The amount of water, the timing of impacts, the stabilization by the moon, the presence of giant planets, the sun's stability, Earth's magnetic field, plate tectonics, atmosphere, and biology all contribute to the planet we know. From far away, all of that is hidden. This is the central paradox. The conditions that allow you to ask the question are invisible in the answer. You can look back and not see the very world that made looking meaningful. If you could see the moon from far away, it would be even harder than Earth. The moon is smaller and darker, yet the moon has shaped Earth's tides, stabilized its axial tilt over long times, and influenced life's rhythms. Again, importance does not equal visibility. A moon that helped shape habitability becomes a vanished companion near a vanished planet. This pattern repeats throughout astronomy. Small bodies can have huge consequences. A collision with a large asteroid helped end the age of non-avian dinosaurs and opened ecological opportunities for mammals. But from far away, that asteroid was nothing. Cosmic history often turns on things too small to see. Looking back also changes how we understand night. On Earth, night is caused by the planet turning away from the sun. But in interstellar space, night is not a time, it is the environment. There is no sunrise unless you approach or orient toward a star. The sun is always in some direction, but its warmth fades with distance. Darkness becomes permanent not because light is absent, but because light is sparse and directional. This would affect human psychology deeply. Our bodies are built for cycles of day and night. Deep space offers no natural sunrise unless we create one inside our spacecraft. And what about the sun's apparent size? At Earth, the sun appears about half a degree wide. At 10 astronomical units, around Saturn's distance, it appears 10 times smaller in diameter. At 100 astronomical units, 200 times smaller than from Earth in area perception, and much fainter. At 1,000 astronomical units, it is tiny. Eventually it becomes indistinguishable from a point to human eyes. This shrinking disk is one of the most powerful visual symbols of leaving home. The sun does not literally shrink. Your relationship to it does. The same is true of Earth's brightness. From far away, Earth goes through phases like Venus or the Moon, depending on the angle between the sun, Earth and observer. Sometimes you might see more of its day side, sometimes less. Its brightness changes with clouds and phase. From a distant telescope, Earth might be brightest when nearly full but close to the sun's apparent position, making it harder to separate. It might be easier to separate at wider angular distances but less fully illuminated. Observing planets is full of trade-offs. The best emotional view is not always the easiest scientific view. This is why the Voyager pale blue dot image required planning. The cameras had to avoid damage from pointing near the sun. The planets had to be captured as tiny points. The image was not a casual snapshot through a window. It was a deliberate act of perspective. Humanity asked one of its machines to turn around and look homeward before it travelled into deeper darkness. That act matters. It was not necessary for navigation. It was necessary for meaning. Meaning is not unscientific. Science tells us what the image is, a small reflected light point from Earth. Philosophy asks what it means that everything human fits there. Both are valid responses. A scientifically accurate script does not need to avoid wonder. It needs to place wonder on the foundation of reality, and the reality is more moving than fiction. No invented cosmic wall could be as profound as the fact that the real boundary is invisible. No fictional glowing orbit could be as humbling as the real disappearance of Earth. Now imagine looking back after millions of years. If you were somehow immortal and still travelling, the constellations would change significantly. The sun's position relative to other stars would shift. Earth's continents would move due to plate tectonics. The climate could change. Species would evolve or vanish. Human civilization, if it survived, might be unrecognizable. The light reaching you would always be old, but over such times the system itself would evolve. The solar system is stable on human timescales, but not frozen forever. The sun will brighten gradually over billions of years. Earth's habitability will change long before the sun becomes a red giant. Eventually the sun will leave the main sequence, expand, shed outer layers, and become a white dwarf. The view from outside then would be completely different. This future adds a haunting layer. If someone looked back at the solar system billions of years from now, the sun might be a red giant or a white dwarf depending on the era. Earth may be scorched, transformed, or gone. The planet's orbits may change as the sun loses mass. The solar system we know is temporary. Its current appearance, even as a star with invisible planets, is a phase. The sun has a life cycle. Home is not eternal in its present form. This makes the present blue Earth even more precious. But in our journey we are looking back now while Earth is alive. The sun is stable. The planets follow their ancient paths. The heliosphere surrounds us. The Oort Cloud waits in darkness. The Milky Way turns slowly. From outside the view is quiet. Inside, life is unfolding. This contrast between outer quiet and inner richness is the emotional engine of the story. If your spacecraft had a window, what would the human eye actually register? A field of stars. One especially bright star, the sun, if you're still within a few light years. Perhaps the Milky Way band. No planets unless aided by instruments and favourable conditions. No Earth, no Moon, no obvious boundary, no visible Oort Cloud, no orbit lines, no glowing heliosphere. If you used a telescope and blocked sunlight, you might find tiny planetary points. If you used long-term measurements, you could reconstruct the system. If you used spectra, you might infer atmospheres. If you used particle detectors, you could map the solar wind's influence. But the naked eye answer remains beautifully severe. You would see a star that used to be your sun. This sentence feels strange. A star that used to be your sun. Of course it is still the sun. But emotionally, the sun becomes a star when you leave its familiar role. On Earth, we do not usually call it a star in daily life. We call it the sun, as if it is a category of one. Astronomy teaches that it is both, unique to us, ordinary among stars. Looking back from outside forces those two truths together. The sun is our sun and a star. Earth is our world and a planet. Humans are central to ourselves and tiny in space. None of these truths cancel the others. The journey also changes the way you think about scale models. In classrooms, we use balls and lamps to represent the solar system. These models are useful but often distort distance. If planet sizes are shown correctly, distances become enormous. If distances fit in a room, planets become too small to see. This impossibility of convenient scaling is itself a lesson. The solar system cannot be comfortably represented at human scale. Looking back from outside is the real scale model, and it says, one light, everything else nearly invisible. There is a kind of terror in that. Not horror, not panic, but existential terror. The knowledge that home can vanish from view while still containing everything. But there is also peace. Earth does not need to be large to be real. It does not need cosmic attention to matter. The value of a place is not measured by its angular diameter in the sky. A human face is tiny compared with Earth, but it can mean more to you than a galaxy. Scale and meaning are different languages. This is where the deep meditative part of the journey becomes important. In silence, far from the planets, the mind may stop asking only what is visible and begin asking what visibility means. Why do humans feel more awe when something is large? Why do we equate brightness with importance? Why do we forget invisible support systems until they fail? Earth's atmosphere is almost invisible from the ground, but it keeps us alive. The magnetic field is invisible, but it shields us. Microbes are invisible to unaided eyes, but they sustain ecosystems. Gravity is invisible, but it holds worlds. The solar system from outside is another invisible structure supporting visible life. If you looked back with gravity in mind, you would not see emptiness. You would imagine a web of influence. The sun curves the paths of planets. Planets tug on each other. Moons orbit planets. Asteroids resonate with Jupiter. Distant comets are weakly held. Passing stars disturb the edge. The galaxy tugs on the whole system. The solar system is a hierarchy of motions. It is music played too slowly and too quietly for the eye.